Joanna Simpson here at Quant Minds International in London. Joining me now is Revant Nayar, Chief Investment Officer at FMI Technologies. Thank you very much for being here.
Yeah, thank you for inviting me.
And just start by telling me, how did your background in theoretical physics, particularly quantum field theory and string theory, lead you to apply these concepts to quant finance?
Yeah, my entry into quant finance was through the machinery of conformal field theory, realizing the fact that these non-relativistic conformal symmetries, which we see in different areas of nature, you also see them in markets, and you can actually use them to constrain these things, these correlation structures, which are used very frequently in option pricing. So it was quite fascinating to me that these symmetries play, I think, quite a major role in finance as well, and can help us solve problems much more effectively than standard ways of doing things, which rely on, let's say, stochastic differential equations. So, following this, chain of thought, I discovered more and more similarities between not just the techniques used in physics and their application to quant finance, but also the research methodology and the best practices and so on. And it was a very natural shift after that.
And could you explain the concept of multi-skill asset allocation in layman's terms, and how does that differ from traditional asset allocation methods?
Yeah. So in traditional asset allocation, you're estimating your measure of risk, which is usually a portfolio covariance matrix at just one scale. But markets, like nature, have interesting dynamics at a range of scales, right? You see, just like you see fractals in nature, you also see a kind of fractal-like structure in markets where you zoom in price and time at a certain rate, you get that your properties of your time series remain kind of invariant. So you can actually exploit these symmetries for asset allocation in such a way that you get a framework which is much more robust to bubbles, crashes, and regime shifts, where standard Markowitz asset allocation fails. So yeah, that was the talk I gave at this conference, which is very well received.
I've been hearing that as well. And how are econophysics principles being used to improve risk management strategies in quant finance?
Yeah, I think this is a very good question, because there's a big buzz around AI and machine learning these days, but there are areas where it fails dramatically, and one of them is things like crash prediction or systemic risk management. And the reason is that you have very few data points for, let's say, pre-crash periods, and most AI machine learning models need a lot of data points. Now, here's where econophysics-based methods come in, because they're based on dynamical systems. They usually have far fewer parameters, so they can work with far fewer data points as well. So I think one of the best models, let's say, of crash prediction I know is the Didier-Sornet log periodic power law model. It just has 7 free parameters as opposed to millions for, let's say, a neural network. But I think one can get even more parsimonious than that. And physics-based methods provide us these methodologies for crash prediction in addition to portfolio optimization techniques, which we discussed earlier.
And through the research collaboration that you've put together with academics from mathematics, physics, and quant finance, what have you found these respective fields can learn from each other?
I think there was a quote by somebody who said that the best work comes out of cross-disciplinary interactions, and I think the same is true for quant finance. I think some of the best ideas have come from people coming from physics, pure math, signal processing, data science. All of these things are very related. But I think what forming these academic collaborations really enables us to do is to stay at the cutting edge of research in all these fields, and also to produce genuinely uncorrelated alpha. And I talk to a lot of investors and LPs in quant funds, and they all complain that all their quant funds go down at the same time. Their strategies are highly correlated to each other. And I found that one way to avoid that is to not just do these academic collaborations and get these fresh ideas, but also hire from them. So we now almost exclusively hire quants who are from academia rather than who are experienced at other hedge funds.
Because you can teach them all the aspects then.
Yeah, they come with a fresh mind, and they view the problem as a pure physics or math problem, and they apply novel insights versus just saying, oh, I know all possible strategies which are there. I'm just going to copy paste a strategy that worked at Citadel or D.E. Shaw here. So that freshness of perspective, I think, is very essential, because we're competing in a zero-sum game. For us to get alpha, we have to create a strategy that's novel and unique and other hedge funds aren't using. So for that, I think collaboration with academics is quite useful, as well as staying at the cutting edge of techniques developed in the physics and math literature.
That's a very interesting approach. Revant Nayar, thank you very much for your time.
Thank you so much.